Welcome to the Manufacturers Podcast, the only source to bring you raw, unfiltered experience from those in the manufacturing and skilled trades world. If you are looking to learn and develop your skills, you found the right place. Strap in and stand by.
So, welcome everyone to episode 6 of the Manufacturers Podcast. So, as you can see, it's a little different this time. We have video. Now, disclaimer: this is my first time running video in a video podcast, so I have not much of a clue what I'm doing. But some of the stuff that we have ahead on the podcast and would like to show now the viewers instead of just listeners, you would really benefit from getting to see this. And as you can see, to my right here, we have our large format, our Resin 3D printer. We've been making a few parts on it, and this is the topic of discussion today, is 3D resin printing. Now, the most popular type of 3D printing, like we talked about, is your filament or FDM style. And that equipment, like we mentioned, you can kind of pick that up for a few $100. I was actually at Micro Center this past weekend to get a longer HDMI cable for my camera, and I stopped by to get an SD card reader. I had to update the firmware on it, and I was surprised to see they had quite a selection of 3D printers. A lot of Ender 3 Creality brand filament printers, as well as resin printers. They have a smaller format resin printer, similar to, you can't see it, but here I have two more up on a shelf. They're the same brand as this big one here. But they have resin printers now, and they stock resin and supplies. So no longer do I have to rely on Amazon. But getting into today's podcast, what we want to discuss is, how to get into 3D resin printing, because, honestly, I have the feeling now with what's available and information resources, resin printing can be just as easy as filament printing. I think some cases it could be easier. And the quality of the parts, the accuracy and precision, it cannot be beat. And that's what we're going to be demonstrating here today. I have a couple parts in front of me. There's a little project we've been working on with our partner, Defense Prototypes. You can see their shout out to them right there. So we are making a half-scale model of a M4 rifle. Now, the reason we chose this, their files, there's something that were available already, and there's a lot of components, not too many, but enough that, so the whole idea behind this project, we're going to build a half scale, an AR-15, M4. It's going to be roughly 18 inches long. That's kind of average, half the length of a real rifle. And almost every single component, down to pins and detents and springs, we're going to print on this machine. Now, that may sound a little crazy to you. Some of the parts are tiny as they are on the full size, and now we're going to make those. But absolutely yes. And that is to showcase the accuracy and the ability of these machines. Now, the one I have sitting right here, this retails for about $700. You're going to need to spend about another $100 on some resin, get a couple different types. There's a few other little accessories that go with it. There's transparent film that you use in the tank. You'll obviously need some IPA, isopropyl alcohol, or mean green cleaner, and gloves, rags, whatnot. They do make a wash station. It looks very similar to this printer, except it has UV lights, which is the process we'll talk about. It's curing, as well as it has a rotary kind of mixer that will swirl the alcohol and clean the resin off of these prints. So that unit is about $250. I'm kind of old school. I have plastic tote containers and, like Tupperware containers. I put alcohol in, drop the part in, shake it up, pull it out, dry it and all that. So, you know, getting into, 3D resin printing, there's obviously, process behind it, just like anything else. But it varies a little different from the filament printers. And we're going to kind of go through a little demonstration, some of the how the parts we're printing, how we got there, and kind of an introduction. And I think now so they have equipment out now, especially this company, the same brand, this machine, which is Anycubic, which is a very high quality imported machine. And that's the very machine I started out on, their original model. This was 7 years ago. I bought it. I had some trouble. There wasn't any resources. Kind of everything was figure it out on your own and trial and error. Now there's so many wonderful technical forums and groups on Facebook and Reddit that it's almost turnkey. So we're going to get into that, and we're going to kind of go step by step how you would approach getting a resin printer. And then we're going to jump right in and basically produce some parts, and we're going to start the machine and let it start printing. It'll probably have, 5-6 hour cycle time, so we won't get to see it finish run today, but you'll get to see the whole process. And I think you'll be surprised on how easy it is. So just first, I have a couple parts here. Now, I don't have a way to control my camera quite yet, but as you can see, we have this 1/2 scale AR-15 lower receiver, and you will see the CAD model here in a second. That was printed last night. I pulled all the supports off it, cleaned it up, cured it, and everything. It looks very good. There's a few little features, I'd like to fix, but this is printed in a generic, like fast printing kind of gray material. It's an economy resin. It's good for proof of concept. It's less expensive so this is about $30 a liter versus the ABS, which is acetylbutystyrene material that I would use. It's really strong and tough. That's about $60 a liter. So I don't want to waste the good stuff, and I can get my features. What I'll do is I'll assemble all these little parts. I'll see how they fit. If I have to make tweaks or modifications, I can do that. The other part I have sitting here, if anyone is familiar with an M4 rifle, you'll understand what this is. And as you can see, that's the support material that I talk about. And if you see here, you'll see that's a little charging handle. It's about 3.5 inches long. And the detail is just wonderful on this. And we'll be posting, we have a couple pictures up. We'll be posting some close-ups of the upper receiver and the bolt carrier and the bolt that it got printed. And that's drying right now. That'll cure here soon. And just incredible. So now this machine is a 6K resolution, which is heads above what I started with. But moving into, so you want to get into 3D printing, but maybe you want to make little miniatures, figurines. It could be a variety of things. You can make functional parts, but you want something that's going to give you good quality and detail. Now, when FDM, the fidelity of your prints is not so great just by the nature of the process. I mean, you can make, cool looking stuff, but the difference with resin is it almost looks molded or sculpted. It's such high resolution, and you can't see it. You'd have to look very close, but it's about 50 thousandths tall on this side of the lower receiver. If anyone's familiar with these, they're usually engraved, fire safe, or full auto if you have a cool one. And I actually was able to get the machine to print that lettering. It's only 5 thousandths deep and about 40 to 50 thousandths tall. And you can look and you can see that lettering on there. That's how accurate this is. So you want to get a resin printer, say you want to try that instead of an FDM, or if you have an FDM machine and you want to get a resin machine. It's literally as easy as, getting on Amazon or going to your hobby store, wherever, 3D printers are sold, and buy one. Now, all of them out there I've seen so far are, in current times, are very good. All the bugs and kinks have been worked out of them. And you can pick up a small format printer. They have some that are $160, $175, and they will roughly have a 2.5 by 4 inch rectangular build platform, and roughly go 6 inches tall. That's about the size of the machine I started out on. I got a second machine, identical, with a little upgraded software and components to make it run a little smoother, which increased the quality. Now this machine here, this has a 9.6 inch build volume, so that's diagonal across the plate. So it's roughly, I believe, 8.2 inches wide by 5.5, and I have over 9 inches of Z height travel. It's more than that, I believe, if you really look at the machine, if you push it to its limit. But then you print something so tall, you might run out of resin. So this machine is very big, but it has a 6K resolution and a whole new UV light system. And so I would say, to start out with resin printing, if it's in your budget, by all means, get a Mono X or a Mono X 6K. They also make a Mono 4K, which it's smaller. It's roughly the size of the original Photon. It could be, they're slightly improved now, but it has many of the features of these big machines. It has adjustable UV. It has a upgraded MSLA or LED display projection system. It has the smooth drive, stepper motors and the twin linear rails. So one thing you would notice different between my old machines and this one. Now the old machines kind of had an aluminum extrusion with like Delrin plastic slides, and that's kind of what held it in place. Now this new machine, kind of in the back here, this column, those are twin 15 millimeter linear rails. Those are precision ground linear rails like you would find on, high-end CNC equipment and lathes and whatnot. So it rides on two of those with a lead screw in the center, and the way the plate mounts on is much different. The old build plate, so this plate here attaches to the column, that's the build plate. The old ones had a ball and socket swivel, so the plate, when you loosened it up, it kind of floated, and you have to level these plates. There's a projection screen here, and right above that, there's this black section here. This is a vat, and it has a transparent film that's attached that keeps the resin from the UV light source. And you have to level the plate. And being on one central little swivel, removing prints from it, you can knock the plate out of level. Now these new designs are so robust and strong. I leveled it once, and I've been printing with it for a few weeks now. No issues. I also have a flex plate, which this is kind of an addition that was done a couple years after. Now this resin, when it cures, it sticks to this build plate, and sometimes it can be difficult to get off. And these plates are sanded or polished smooth, and you can scratch them up with scrapers, and it can be hard. You'll break prints, and So now there's a magnetic, uh, it's like a magnetic tape almost. It's about an 1/8 inch thick that sticks to the build plate. And then there is a steel plate, a flexible steel, spring steel plate that attaches to that. So it'll print. I can pop that right off and I just flex it and all the parts drop right into the vat. So, starting out to get a machine, there's a couple brands. I would definitely recommend Anycubic. Then you also have Eligoo, and which their brands are the Mars. That's their small machine. That's their kind of entry level. The Eligoo Mars was one of the first 3D resin printers, and it's a very good quality one. Another brand is Frozen. It's spelled Phrozen. And that is another good company. So Anycubic, Eligoo, and Frozen all make entry level resin printers for under $200. And they all have 4K options. So high definition with an upgraded LED display instead of a DLP. So when they first started out, they were DLP, which is digital light projection. And now these are MSLA, which is masked stereolithography. And then you have then there's like LED displays, and there's a few little differences, but these are much more advanced. And you can get a middle of the road printer, kind of in build volume wise. They make one called a Photon SQ, which stands for square. It's 4.5 by 4.5. And then they make the Photon Mono, which is the small machine. It's like $169 or $165. You can get a package with a wash station and the printer and like a liter of resin for around $400. And these machines will come with like a starter kit. They come with a USB drive. They come with gloves. They come with filters, like paint filters, for screening off your material in and out of your container and your vat. Gloves, face masks, all of that. All the tools to adjust and work on them. Extra screws, extra FEP film. So I guess the basic components will kind of go down it here. So now, I kind of alluded to, if you want to get into resin printing, kind of decides on, it's kind of based on the size of the parts you want to be able to make. If you want to be able to make parts that are more than 4 inches long or tall, you're going to need a medium or large format printer. So a Photon SQ or the Mono X series, or an equivalent in another manufacturer. So once you've decided, this is the machine I need, it's basically all based on build volume with these things. They all they're all open source, so they run the same materials for the most part, and they use all the same FEP. It's all generic. So, once you pick out your machine, you know which one that is going to suit your needs, and what's within your budget. Then you're going to want to think about, like what the quality is that you're looking for. If you want something very high definition, then we're going to need to, go into the 4K range, which is the resolution. Just like your TV and whatnot, 1080p, 720, then you got 4K. So this will get you very high definition. And that also, with these upgraded LEDs and the high definition, it also prints faster. So if you're looking to make like 32 millimeter models or miniatures, which that refers to like the height and the diameter, height or diameter, they're real popular for, you have like World of Warcraft and Minecraft and PUBG or whatever. That's not really my thing, but I know there's tons of miniatures out there, and people print them and they get into airbrushing and all that. You're really going to benefit from a higher resolution machine, and they're going to print quickly. You could print those miniatures in roughly an hour, and you could load up the build plate. People make custom chessboards, um, all kinds of stuff. So there's those are the factors. To first think about the size you're going to need, your price, and then the quality of the prints that what you're looking to make with it. So and then once you pick that out, also to consider in your budget is some of the things that you're going to need to go along with this. You're going to need FEP film. It's a translucent or transparent film that attaches to the bottom of this. You're obviously going to need a supply of latex gloves. This stuff is messy, and you're not supposed to get it on your skin. I've touched it. It's not like toxic, but there is health warnings behind it. Disclaimer, I'm not telling you what to do with it, but you want ventilation. There is odors to this. So you want a good room, it's ventilated. So there's going to be some supplies you're going to need to buy. You got to buy alcohol and your isopropyl, at least 70%, preferably 90 to 99%. That can be upwards of $18 to $20 a gallon. Or mean green cleaner. They do make water soluble or water washable resins, but they're kind of lower quality. So I don't mess around with them. But you're going to need supplies to wash your parts, like a tub or a wash station. And then, if you want to add on things like a flex plate or, a custom enclosure. So these do require to print a certain temperature. So if you have to put them in a basement or something, you may want to, have an enclosure or an area for them. So those are all things that you got to think about, and you'll get kind of a total price. So generally, the rule of thumb is whatever the machine cost, it's going to cost you 50% of that in your supplies and what you'll need. And besides what you'd have to buy, there's a few other things that you're going to need. And they're free, and that's computer software. And which will lead us into something here we're going to do next. There's a multitude of software. We talked about in our CAD episode about Fusion 360 or SolidWorks or what have you. So we have up here today. I'll show you Fusion 360, how I brought the part in. We won't get into modeling, but basically I create a part, and then you need a slicer software. So to create these models, now imagine this model, and for the computer and the machine to be able to read this, and it has to create layers. So it's going to, by thickness, what you determine, and what I run almost always is 0.05 millimeters. That's roughly 2/1000ths of an inch. It's going to break this model up. However it's oriented, it's going to create 2,000 slices until it reaches the top of the model. And those are going to create profiles, and then my light screen will, mask those and project them. So you need a slicer. There's a bunch of free ones. Now, Anycubic, it comes with a slicer. It's more than capable of most things. But as with anything, there's always custom and higher end options. Now, there's another software I use. It's called Lychee Slicer. It's open source. There is a free and a paid version of it. The paid version lets you get a little more customized with your supports. If you're making highly detailed miniatures or figurines and you want to customize your supports to not disturb certain features, you can do that. But Lychee will analyze, repair, all kinds of stuff, the models that you get, you bring in. And then from there, I kind of have a process. I'll take it from there into Photon Workshop, to slice it, because as of now, I know the photon slicing software is most compatible with the machine. There's no issues of error, so I always try to, bring that in and use that. So let's say you pick out your machine, um, you decide which one you want, what you're going to do. Most of these machines will come with like an economy resin. You're going to need to pick out a resin. Uh, Sorry, guys, there's a little bit of fume coming from this machine. I had it turned on earlier before I started this, so and I didn't open any windows or anything, or I didn't get my fan going. So don't mind me if I've got a little head action going here. But you're gonna need resin, and there's a lot of different types of resins, and we'll talk about a couple. Uh, you have kind of your standard modeling resin. Then you have what we call engineered resins, and then specialty or custom resins. So an engineering resin is something that is designed to fulfill a specific purpose. That could be optical clarity, that could be high temp resistance, strength, toughness, hardness. It could be flexibility. Sometimes flex resins fall into the custom or specialty category. And then we have in that specialized or custom category, you can have things like flexible resins. There's additives, things that like a flex additive, and you also have casting resin. So it's a wax type or waxable casting resin for doing lost wax castings or dental work. It's common in that area. There's also medical grade resins. You have high precision resins, which they're very brittle. They're not strong, but they're able to print very accurate details. And of course, you have your generic resins, which are great. And I would say pick up a couple bottles of resin to start. Sometimes they come with one. Usually it's a gray or a green. They're standard green. The gray resin is real easy to print with. It seems like no matter what manufacturer it is. If you're running an Anycubic machine, I would try to stick with Anycubic resin, unless you want to get into some type of engineered resin. Now, I run a brand called eSun. It's a ABS-like tough hard, and I've worked with it quite a bit, so I'm able to, get successful prints. Sometimes engineered resins need a little extra work to tweak them in. And then I also have some flexible resins. There's a manufacturer called Soriatech who basically makes only engineering resins, and a lot of their stuff is meant to be mixed either with another product they make or with any standard resin that has the same exposure wavelength, and you can create custom properties, things that are strong but have like a little give. Something like a phone holder, a pen holder. So like it'll snap in, so to have some rigidity, so it'll retain that, but it has enough flex where it won't crack or kind of like bend or spring, and it'll have memory. So you're gonna want to pick out your resin. Definitely need some of that, and so get your printer, get your resin, you got all your supplies and accessories. You're gonna go on to Google Chrome or whatever browser. You can go to Autodesk, download Fusion 360, the hobby version. Then you can go to Lychee Slicer and download their free version. There's also another slicing software called Chutubox or Chitubox. I've used that in the past. I don't use it now because they don't have my new printer file type on there, so I can't process a file or export it out of their slicer if I wanted to. But it is good for, like automatic or manual supports. There's a lot of good tools. So get your CAD software. Now, you get your machine. There are so many YouTube videos out there for all these machines now. But you can, follow the manufacturer's instructions. And I did on this machine just for the fact, to be able to show people how easy it is. Step by step, there was a manual that came with it, how to set it up. First thing you're going to do when you're going to unbox it, you're going to get all your parts out, you're going to put your build plate on. If you're getting a flex plate, you're going to have to mount that. It takes like 48 hours once you stick your adhesive pad down. Besides that, your tank will come preloaded with an FEP. So you can install your tank, put your plate on. You're going to come into your software, which we'll do next, and you're going to get a model. So with Fusion 360, you can see I have this model in here of the AR-15 lower. This is something I started out with a generic lower, and I modeled a lot of features on. This was one I was going to custom machine, and I decided to do a half-scale model. So we won't go through all the modeling, but you can see it's a 3D model. And with the utilities, right in Fusion, I can make this an STL file. I'd output it to wherever I want. I already have this file. Now, basically, once you get your STL file, if you go on to Thingiverse or you go on to GrabCAD and you get a pre-made file, a lot of them will be in STL format. If not, you can bring them into Fusion and do that. And once you go through Fusion, or whatever CAD you have your STL file. It's important that you have the STL, which stands for stereolithograph file. Once you have that, we're going to be able to bring it into our slicer software. So now, this is just my preference. You can use Photon Workshop or whatever manufacturer or brand machine you have. A lot of them have their own slicing software. But if not, it's no problem. And this is why I recommend getting used to something like Lychee or Chitubox. So in case the machine you decide to get doesn't have a slicing software, that you will be able to process your files. So this next software I have is called Lychee. And I will show this to you. Hopefully it'll come up here. Yeah, here we go. So this is Lychee. It's a slicing software. Now, I had preloaded these parts earlier today. This is what we call a scene. So I have, here, Lychee is very intuitive. I can choose my printer. So I have my printer set up here. I can actually choose a resin. Now, I have my printer chosen. I can actually choose the brand of my resin. They're not all on here, but there's quite a library. So when you save one thing I like about Lychee, when you save your settings and you make a print, the next time you open it, it'll ask you how many, how it came out, and it'll report your settings. As you can see here, 58% of the, people that report, had good outcomes. So I can pick like eSun. I can pick the hard tough. I can pick the colors. So they only have the blue. The blue would probably be very close to the black because they're both opaque. They're not translucent. Oh, my bad here, guys. So I can pick eSun. Or what we have in here now is our Anycubic standard gray, rapid basic standard gray. And these are all settings. So the higher, now I can tell you what I'm running is not on here. There are more settings. We can go through this. I see some that are close to mine. And when I say, you know, when I say that it wasn't quite close, you know, you have to tweak this stuff in. And I accidentally closed out Lychee, guys. I apologize for that. I thought I was closing out the resin menu. But there's one thing you can do, and that's validate your prints. And we'll get to that here when we move forward. So while we're waiting, it's loading back up. Cool. Decline. So now this is actually good. Now I can show you how I do this. So we're going to file, and just like most things, we can import a 3D file. Now I have some here already to go. These are STLs. Now this is the second part scene, so I'm going to select this. It's going to analyze, it's going to load, it's going to go through all of this, and it's going to bring these parts up. So we have all the parts here. So now these are all the parts left for the machine that I'm here I want to move this. So we have options. We can scale, we can rotate, we can move. We can do a lot of different things here. We can also, the most important thing with Lychee, once you import your models, we're going to pick this scene. I can generate supports. Lychee is very nice. It will analyze the different objects. So this one's going to take a few minutes because it's registering them all at once. Now I saved this as a STL, so it thinks everything is one part. I also have the scene file on my other computer, so where all these parts are individual and I can move them around. Now it's going to analyze, so it's going to go through, it's going to determine, the angles of everything, all the features, what the best route to give supports are. Then it'll do a couple of things. So here it's adding supports. So essentially, you're going to run your parts through here, no matter what it is. And if there's anything wrong with them, if they have any invalid geometry or voids or artifact pieces, then this will actually, as you can see now, it's generating supports. It will actually repair your models for you. So here it's going to optimize them. Basically, what supports are, now these objects, if we were to print right off of the plate, which we can do for some things, but if we were to print right off of the plate, you get what's called an elephant's foot or a burn-in layer. And because we intentionally overexpose the bottom layer to make sure it sticks to the plate, then you actually get kind of a flare, or you get like a ridge that develops because we're overexposing the resin. So you would have that in your part. Now you could sand it out, or you could add extra material to the bottom of your part that will allow you to grind it off or sand it off. But if you bring the part up off the table, then you can use supports. So it's going to print these little pegs, or these little fingers. Those will be on the table. And as they print up, they will connect with your part and they will support it. They will help it maintain its shape correctly. And now they touch the part at different spots. Now the downside is you have to remove these and then you have to sand your part. If you have certain shapes, as you can see, like this gas tube or some of these round pins, if it's kind of vertical, I would be able to print that straight up off the plate. Uh, we'll let that run for a minute, and I could print it straight up off the plate. Probably knock the edge of it off with sandpaper, and it would be fine. So, as you saw, like with this, charging handle, I put supports on that. It printed straight up. So here we go. It's done. It's finished now. So it just told me, it's giving me a report. And what it's done is it's went ahead. It's lagging a little bit. I have a lot of software open, guys. But there we go. I'm trying to zoom in. I want to show you what it did here. So you can see these braces. So it's added braces. It's connected these to kind of make them rigid and to stiffen them up. So it'll support this. Now this will print layer by layer. And the reason I put some of these on angles is if they have a lot of surface area, when this machine cures, it's going to come down and it's going to solidify the layer, and it has a little bit of stick or a little bit of suction or friction to the film. And if you have too much of a surface area, it creates a lot of tension, and you get hydraulic tension as well because it's liquid, and it runs a chance of breaking these supports off or breaking the part off of the print table. So generally when you put things on angles, you reduce the surface area and you can print straight up. Now, these are flat to the plate, and some of these other things like this little button I could probably print flat. They're not very big. They cover a little bit of the surface area, but not a lot. So once we have it, we have it light sheet, we created our supports. We'll simply export that. Now I keep it in an STL file from there, and the last thing I'll do is bring it into this Photon Workshop. So this here is actually the slicing software that comes with the printer. And now I can open this up. So here's all the parts. Now I didn't save it out of Lychee, but it would be the same process. I can do supports here in Photon Workshop. I'm not a big fan of their supports. They're not great. They're kind of basic. You would be better off doing manual supports instead of automatic supports. And what you can do is slice. So we can have our settings. And if you see here, I have my machine set up, and I run advanced control. This is my default setting for the gray. As you can see, I run 1.6 seconds exposure. Now off time. So this is a big machine, and where the plate's coming down and it has to push the resin out of the way to come down to 0.02 of an inch. So when that comes, we want to give the resin time to settle before it exposes it. So I have a long exposure off time. We have bottom layers. Sorry guys for yawning. Trying to get this video out to you guys, and unfortunately life hits us. Here's the real part of manufacturing. I've got a 7-month-old son who likes to wake up in the middle of the night to eat formula. So sometimes by the end of the day I'm a little tired. But we can do all our settings here, and we're going to do a part 2 video where we actually go through and kind of cover all these settings and what stuff like anti-aliasing is. But essentially, now we're to the point we got our machine, we've set it up, we followed all the manufacturer instructions. We got our bottle of gray resin here, and we shake it up. You have to shake the resin to mix it. We pour some into our vat. We put our models through the CAD. Now we're going to make our settings. So we have our settings here. It's basically the speeds that it moves up and down at and the amount of time it exposes a layer and whatnot. And this will all generate, the time. So then we'd hit like slice. Now this may take a little while. Photon Workshop's not the fastest slicer in the world. And these are tall parts, so it's going to break it down. But that's less important anyway at this moment. So now that we have everything is sliced, now my video might slow down a little bit because the computer's working hard, so I'm going to cancel this. It's killing my graphics card here to run that software. There we go. So we got everything sliced. I already have a file here on my USB drive. So I'm just going to stick the flash drive into this machine. Now this has been sitting here for a while. I want to stir up the resin. So I'm going to home this machine. You see the plates dropping down. I'm going to home it a couple of times. I'll kind of just stir up the resin. Some of the air has already floated to the top. See, it's moving slow. Do it one more time. Third time's a charm. Okay, I'm going to hit print. Let's see here. All right. Then we just hit print, and the machine is going to go. So let me actually throw a different file on here for you guys. I just had an idea. Well, next time we do a video, I'll be able to show you guys this. Look at this, man. Show you real quick how we can slice apart. So we can get this on an angle. So just going to snap it back up to the surface of the plate. We're going to do heavy fill. Let's move this up a little bit. That way you can support it. It's going to take a little bit to print this thing. So I probably won't kill my video while we're slicing it, but It's still on 80% with the supports. I had some files on that flash drive. They're the parts that I already printed, and they look pretty good. So I only have, actually, this gray I have is all that's left in this bin. Um, yeah, this is going to take a while to slice this. See, I went ahead and tried to do something cool for you guys, and now this software doesn't want to help me out. Photon Workshop's a pain in the ass. It does good for, for what it needs to do, but there, I just close it out. I'm done with that. Let me get rid of that here. All right. So anyway, you know what? I've got something else on here. So all right. So now it's going to run through its printing. We're going to make another one of these lower receivers, and we're going to give one away. All right. So the first person, we're going to make an Instagram post tomorrow when this is done. The first person to comment or like or respond to that post to get a little mini, we'll throw a keychain on it for you. All right. So the machine's printing. You're going to watch. It's going to go up and down. It's going to sit there and do this for hours. It's going to build layer by layer. So once we're done with that, and this is going to be something we'll probably get into in the next part is post-processing, because it's kind of a whole in-depth thing. But it's going to print the part. When we get it done, we got to clean it. We got to post-process it. So we're going to clean it with alcohol. We're going to dry it. And then we need to put it under a UV light. So that's one more thing. If you don't get a wash station, you have to buy a separate UV light. You can buy, they have like little UV blocks for $15 on Amazon. You can mount it, to a piece of wood. And I have a little solar rotary table. It costs like $5, and it'll sit there and spin the part on it. But, to get it, so kind of summing it up, to get into resin printing, you saw how easy it is. The software, I have my recording software. I have my slicer open. I have Fusion 360, which is huge CPU eating software. And, Audacity, some of my audio editing stuff. So this computer here is just getting bogged down. But you get your software, you get your files processed, you get them printed. It's very simple. I know it may seem like a lot of steps, but it's just a checklist. And we may even come out with a little checklist image, that you can print out and kind of go through it. But, there was one day when I was brand new to this, and it was tough because the technology was still in its infancy. But literally, this machine, I unboxed this. I set it up right to like the little pictures and everything from the manufacturer. Load it. I had a file. They come with a test print, so there's a test file on here. Put your resin in. Hit play. That's it. There's a little play icon when if you can see the screen, there's a little start, stop. It's a play button. It's all touch screen. There'll be little logo, little icons with like a little tiny display of your part. You just pick that and load it up and go. I mean, it's that simple. These things are kind of turnkey now. And there's a lot of people that are making files that are already pre-supported. You just download the file and slice it. You don't even have to add supports. Um, so it's getting very easy now. And if something goes wrong, you can take a picture. You can post it on one of the forums or on the Facebook pages. And I guarantee within 15 minutes, somebody will be telling you exactly what to do to fix things. And we'll touch on some tips and tricks in the next video. This will kind of be a part one. This is getting you into it. Part two, we'll go into cleanup, post-processing of the part. Um, I'll have some files like ready to go. I had a lot going on today, and I brought in I had to first convert all these files to an STL and then scale them down 50% and nest them on the plate. And I didn't have time to slice them or to get supports on all of them. But we'll touch on that, and we'll maybe do a little demo, kind of show you a manual support job where we put supports on ourselves and kind of where you would want to do that and how to look out for, supporting your part. So I hope you guys enjoy this. It's my first time on camera, trying to run my overlays, and this is the little studio here. This is a room that I refinished. I just put a TV up on the wall. This is my man cave. I got a couple printers here. I got my deer mounts in here. I got a fridge. Everyone needs a fridge. I got a full-size fridge here for all the beer and other delicious beverages. I got a nice chair. I got my storage shelf with all my supplies. This is where I hang out in the evenings, watching football. I just got my Roku TV, so now I can come down. Hopefully, I can get some people that want to come hang out, 3D print some parts, do some podcasting and whatnot. I appreciate you guys, and I thank you very much.